Hey guys, so welcome back to our session on number systems in the playlist of quantitative aptitude for CAD and other management exams. So, as since the beginning of this sessions, I have been saying that there are several scenarios where you will find this topic to be the core foundation of other type of mathematical or quantitative questions. With that said, let's begin our new advent in this series. And this time around, we are going to be determining how to find the product of factors, all the factors of any given number. Because so far we have determined the number of factors, sum of factors, and even several questions based on them we have solved. So this time around, let's get it with the product of all the factors of those numbers. So as usual, we'll take the same old example. So all of you have left that blank space and you can use it around this time. So for product of factors or POF for short, we know this part. We have done it several times that 528 equal to 2 raised to 4, 3 raised to 1 and 11 raised to 1. That's quite clear. And total factors TNF is 20. This much we all know, right? And product of factors is simply nothing but 528, that is the number itself, raised to the TNF divided by 2. That's it. And the answer of this value, that is going to be the product of all the factors of the number that you have. Oh, wait a second. These guys just always, let me just take this call.
No way. No way it's going to be that simple, sir. Sir, I don't think this is fair. Just because Kelvin and Borobot are always making a fool of themselves, I don't think it gives you the right to make fool of every student here, sir. Sir, we don't believe it. We don't believe it can be this simple, sir.
So yeah, I'm sure just like these guys, many of you don't believe me because how can it be so simple, right? Anyways, as you don't believe me, I will prove it to you. As simple as that. Because maths can always be proven. So here it is. Now for the proof, let's start with small numbers which you are acquainted with, like 12, 16 and 20. So 20 can be written as 1 into 20, 2 into 10, 4 into 5. These are its factorization that you all know, right? It is a simple number and all of you can do, and TNF is 6. So I can write the product of factors like this: 1 into 2 into 4 into 5. I just wrote them in ascending order. Pretty much clear, right? Now, if you will focus on the color combination that I have given to these numbers, like 20 and 1, they are blue, 10 and 2, they are green, and 5 and 4, they are orange. The reason for doing that is just to, to make you guys click your imagination that if we are multiplying these numbers, what will be the quickest way to make it simple? As you can see, these are making pairs. Pairs of what? 20 into 1, 20. 10 into 2, 20. 5 into 4, 20. So what am I observing here? I am observing I have got 3 pairs of 20 multiplied to each other. That is nothing but 20 cube. And this 3 is nothing but number of pairs. Pair has 2 values which are factors. So total number of factors got distributed in pair and exactly got divided by 2. That's why the method I provided you was just use the number itself, provide it the power that TNF divided by 2 and you will get your product of factors. Quite simple, right? So this was the logic behind it, that you are distributing the total number of factors or the total factors themselves into pairs. That's why they were getting halved, whatever you say. And you better check the pronunciation for HALVED. What is the actual pronunciation? Do let me know in the comment section what you guys think. And yeah, of course, if just like you like your classmates who ask the questions, if you guys find this quite useful, a sub to the channel would be quite unbelievable. And of course, you guys can also like the video and share it with your friends who are also aspiring for mbaentrance exams. That would be great. Now, similar to 20, you guys can also do the same practice for 16 and you will find that here there is something different. The reason being 16 is a perfect square. So the pairs, I am getting a same number twice, 4 into 4. But I am getting 3 pairs, right? The pairs I am getting is 3. But the factors are 5. So if I divide 5 by 2, I am getting 2.5. Or I can write it like 16 into 16 into root 16. Because product of factor, I cannot write 4 2 times. My factors are 1, 16, 2, 8 and 4 just once. 4 has to be coming only once. That's why I have to write it like 16 into 16, that is 116 to 8. These are 2 out of the way. And 4, I can write it like root 16. So that is nothing but 16 raised to 2.5. So you will notice that my trick of just dividing the TNF by 2 also works here, because if you divide TNF by 2, you will be ending up with 2.5 anyways. So yeah, you can write it like this as well. So even in this case, you will find that right, you just need to always divide the TNF by 2 and add that as the power to the number, and you will be done with your product of factors. Quite simple, right? Now let's get that in practice. So find the product of all divisors for this number. Go ahead, pause the video and write yourself. And of course, for many who are struggling with English, I will let you know that divisors, whatever you say, is nothing but the factors or the number which is going to divide 84100 completely. So I will now begin the solution. I can write 84100 like this. I'm smartly splitting it, nothing else. And if you guys have remembered the square or cube table that I have provided you since the earlier lectures, I'm sure you guys can pretty much figure out this quickly. And these are my main factors, prime factors, or I can say, and total number of factors will be 27 based on permutation combination, as you guys know. So product of factors, quite simple, 27 by 2 and 84100 raised to 13.5. And this 0.5 I can write it like 290, because 84100 is nothing but 290 square, but I got only half power, so I'm writing like this. Do find out the final answer and let me know in the comment section what is the final value of this, right? Okay, moving on. This is basic maths. You can easily complete it. You will be provided calculator in majority of the exams. So they are not expecting by providing such a great number that you will be mathematically calculating this manually. If in exam such a question comes, they will be providing calculators. Okay. So this part you can do with calculator, no issues there. Moving on to next part. Now, again, similar question. You need to find POF for 1080, and extra condition is there that 1 and itself are to be excluded. That means 1 and 1080, these two are to be excluded from the factors. Then you need to find the product of factors. Quite interesting, right? So we will do the same thing that we have been doing, nothing changing till we find the TNF. And even for POF, product of factors, we will only divide it by 2. So we will be left with this. Now, coming back to our that extra statement where we had to remove 1 and itself. So what is that pair? 1 into 1080, right? That is just a single pair. That means I only need to reduce this power further by 1, or either I can reduce the TNF by 2. Because I am reducing two factors, total number of factors I am reducing by 2, or either I am removing one pair. So you can suit yourself and try whatever, because here coincidentally 1 and one number itself, they are forming one pair, but in all of the questions it is not going to be the same. Sometimes the factors that they will provide in the condition may be different, then you will need to reduce the TNF, and sometimes it may just work. So here it is quite simple, 1080 raised to 15, that is going to be our answer. Moving on again with a bit of different approach. So in how many ways can I express 52900 as product of two different factors? So again, this is not directly asking the product of factors, rather it is asking the number of ways in which I can express this number as product of two different factors. And you better be paying careful attention to the wording of the question, because this is going to be a tricky one, you guys. So again, TNF, it is going to be the same, and total number of pairs I have already clarified. You just need to divide the number of factors or TNF by 2. So you'll be left with 13.5, right? Now, a very basic dilemma, what to do with this 0.5? Well, nothing. Because if you pay mindful attention to the question, it is clearly stating it has to be two different factors. And no matter how I put it, 230 into 230 is not a product of two different numbers. They are the one and same. So obviously I can only write it like 13 ways in which both the numbers are different, and I'm still getting the final product as 52900. And what difference does it make if I just remove this different? I will have 14 ways. So this 0.5 is, like the middleman. And then you need to look at the question for whether you have to reduce it or whether to increase it. That's the way you go around such type of question. So better be careful about the such wordings in future, right? Okay. Our final answer is 13 in this case, as this actually needs different factors. So yeah, otherwise if different was not there, 14 was the answer. So let's move to the next type. So from the last question, I am pretty sure that it might have piqued your interest. We are writing them like product of two different numbers, right? But what if those two numbers are coprimes? Then what do we do? How do we exactly get that value? Now that's, I think, is very interesting and quite simple as well. For this time around, I will be taking a different number, and don't worry, that blank space you have left, keep it ready. We will use the same old number again, but just for this instance, I will use a different example, for fresh air or fresh space. So yeah, 360 we all know is going to be factorized like this. You guys can try it out yourself. And co-prime pairs we are going to find, right? So co-prime pairs would be something like this: 8 into 45. 45 and 8 don't have HCF anything other than 1. Both of them are going to be having 1 as the only common factor. Similarly for 40 and 9, 360 and 1, and 5 and 72. These pairs are having highest common factor as 1. Apart from 1, there is no common factor. So these are co-prime pairs for 360. Now, how do you go about, of course, there are only 4 ways to write this, but is it feasible to do this process? Because I got for sure that I know, because I picked this question obviously, that these 4 are going to be the pairs. But in exam, how will you go about it? That's why we need a shortcut, your favorite thing, right? That you always use shortcuts anyways. So now it's time for our old new number to shine again, 528 as usual. If you guys didn't notice, the number of coprime pairs, we can write it like this: 2 raised to n minus 1. Now this n is the number of prime factors that you see in this factorization, because these are giving the permutation and combination of them being co-prime to each other. If you take 1 as prime, whatever is left would be co-prime to prime number itself. This is a smart permutation combination that we have applied here. So here we have 3 prime numbers, 2, 3 and 11 at the base, and we have to reduce it by 1. We will get 2, then 2 raised to that value n minus 1. I will be left with 4. So yeah, 528 can be written like in 4 ways as product of two coprimes. Quite simple, right? So all of these are always rotating about the total number of factors. So in any case, you need to find total number of factors before solving any of these. So yeah, here goes the next question. 52900, you have to express it as product of two coprimes. And till TNF, all of you guys know how to do it. You factorize it, take the powers, add 1 and multiply them. You will be left with 27. And as you see, the base, I have 3 prime factors. So I will reduce it by 1 and add it to the power of 2. I will be left with 4. So yeah, even 52900 can only be written in 4 ways of product of coprimes. 2 coprimes to be more precise. If you cannot put the coprimes and add on new values, we are talking about 2 coprimes pair. That's what you need to do. There is also way to write it in the way of 3 coprimes product, right? Okay. So these are questions for you to try yourself. Yeah, these 3 values you have to find the 2 distinct divisors and 2 coprimes. Better be careful with the wording. I am sure you guys can Google them and understand what these mean. So do let me know in the comments what the answers are, and see you guys in the next lecture. Thank you.